Hello, everyone, and now continuing the series of hypothesis testing, I'll be talking about a very interesting distribution known as chi-square test of for hypothesis testing. You can write it like chi-square test. That is exactly what it is. So it is a square test. That means this is always a positive test. That means the curve of a chi-square, if you see, it is exactly on the positive side of zero. There's a bump right in the beginning and goes like this, tapers down to x-axis. This is x-axis. This is y-axis, and that's what chi-square test is about. So if you could recall z and t test, they were actually on the both sides of the zero, negative values and positive values, but it's always towards the positive side. It's kind of replacement of t test when the observations are at ordinal level or less. So I don't want to fall into that, but how do you calculate a chi-square value for testing the hypothesis? Again, recall, the overall process of hypothesis testing remains that six-step process itself. So a chi-square value can be calculated by O minus E square divided by E. What is O and E? O is observed values, so it is observed, and E is expected values. So fundamentally, we try to calculate a deviation between observed and expected, square it up, divided by the expected value, and find the chi-square value. There are two utilities of chi-square test. One is known as goodness of fit, which I'm not talking in this video. That means if let us suppose somebody says that average accidents on a particular road are 10 in a week. You observe the data for 5 weeks, 6 weeks, and you find the average, and you actually try to see that your observed data, how much it is differentiating from the quoted average value. Second is called independence of attributes. So many times we talk about, uh, you know, two variables which are impacting each other. So probably gender is impacting choice of color. Gender is probably impacting the selection of a particular specialization or something of that sort. So we try to see that whether gender is actually impacting this choice of color, or whether gender is actually impacting significantly something else. So instead of gender, you can take any other variable. So there are two variables. You try to test whether they are independent of each other or they're creating impact on each other. Interestingly, for any alpha value which remains a challenge, how do you see a chi-square value? So again, I'll just load up a table here. And if you see here, this is how the chi-square table looks like. Let me change the pen color once again, take it a black color. So if you see, there are degrees of freedom which are given here, and there are alpha values, and everything is positive. It's a chi-square value. So it's an easier table to watch. So if I'm looking into something called 1 degrees of freedom, 5% level of significance, the chi-square at alpha. So how exactly how do I write it? So I write it something like let me make another color here. So I'll probably put up something called chi-square at uh, you know alpha 0.05, 1 degrees of freedom, and that value is actually 3.84, which I've just circled. You just see the degrees of freedom here, and you see the chi-square value of alpha here, and at the intersection, whatever value falls, that becomes the value of chi-square. Let us straight away jump into an example of independence of attribute. So what I'm going to take is I'm going to take a data. So let us suppose there is some data of this kind, that you have males and females, and you have a preference of beverages. So I'm saying preference of a Coca-Cola, and and there is a preference of Pepsi, preference of Pepsi. That means, and that's how the data has been given. There are, there in the university or probably in a campus or perhaps in a school, some data is collected, and that's how the values or the observations are actually reflecting here. So there are in total, you see 46 males who said they prefer Coca-Cola, and there are 14 males who said they do not prefer Coca-Cola and they prefer Pepsi. 32 females, on the other hand, said they prefer Coca-Cola, and 28 females actually said that they prefer Pepsi. And if you see their total, there are 60 males. You can sum it up, and there are 60 females. And same way, if you there see there are 78 people, 46 plus 32 prefer Coke, and 42 people prefer Pepsi. And if you see their total, the total is that's the total. It is 120. There are all in total 120 people surveyed. So these are all observed values. So I write O in front of them. So these are observed values. Observed value is 46, observed value is 14, observed value is 32, and observed value is 28. While I am going to fix up another value here, which is called expected value. And what is the expected value? Clearly see that. The expected value for this cell would be 60 multiplied by 78 divided by 120. So corresponding row value, corresponding column value, and that is divided by 120. So expected value, I'm simply writing it 1 1. That means first row, first column. It is actually 60 times 78 divided by 120. And what do you get here is 39. This value is here 39. Let me calculate expected value in this cell once again. And that is going to be expected value of first row and second column. That is going to be 60 times 42. You can see the corresponding row value is 60, corresponding column value is 42, divided by total 120. And that gives me a value of 21, right? I am going to calculate it for second row, first column, that means right here. And that is again going to be 78 times 60, or 60 times 78 divided by 120. That is again going to come out to be 39. And I'm calculating expected value here, which is actually second row, second column, which is again 60 here, 42 here, corresponding row and column, and divided by 120. And that comes out to be 21. This is pretty simply 21 here and 21 here. Sorry, I forgot to write it. So I have observed an expected value. Let's go 6 step. This is the fundamental calculation which you need to do. Let's go with our 6-step process of hypothesis testing. I'm going to set up my null hypothesis first of all. That means gender doesn't impact choice of beverages. Oh, mind me the spellings. While alternative hypothesis is gender impacts the choice of beverage. Or you can simply write it H0 is not true. Choice of beverages. Oh, okay, that's step 1. Step 2, I have alpha value. Let us suppose I want to test it at 0.05 level of significance. Step 3 is calculating. I'm going to calculate observed and expected. Step 3 is pretty simple. Step 4 is identifying critical reasons of rejection. For that, I need degrees of freedom. Now, degrees of freedom here is going to be row minus 1 multiplied by column minus 1. So if you see how many rows are in this particular problem, there are 2 rows minus 1 multiplied by, there are 2 columns, and that is going to be 2 minus 1. You solve it, you come out to be 1. So 5% level of significance, 1 degrees of freedom. You can check the table back here very quickly. 1 degrees of freedom, 5% level of significance. The value is actually 3.84. So you can see it is 3.84. I've already circled it. So it is 3.84. And what is going to be my rejection and acceptance reason? I'm going to draw a curve here. Okay, sorry, that's not how the chi-square curve looks like. I'm still on the hangover of t-test or something. So that's how the chi-square curve actually looks like. and this is 3.84. So there is no positive and negative, and this is going to be my rejection region. Let us calculate chi-square value. We know the formula. It is sum of observed minus expected square divided by e. So I'll again write it in a better way. Just a minute. Okay, that is going to be observed minus expected square divided by expected, and that is simply going to be something of that sort. Like I go with the first cell. It is going to be observed is 46, expected is 39, square divided by expected value 39, plus the second cell right here. It is going to be 14 minus 21 square divided by 21. So I'm putting up expected values at the bottom, plus I'll go with the third cell here. 32 minus 39 square divided by 39, plus, and I'll go with this, observed 28 expected square divided by expected value, and I calculate this. Once I finish up the calculation, I'm going to get something like 0.0073, which is way below this zero writing. So what is my conclusion? Do not reject H zero. So that simply means that gender doesn't impact the choice of beverages. The, the choice of beverages and gender are two independent variables. So that's chi-square distribution for you. This table is 2 by 2. There could be bigger tables 3 by 3, or it could be a 2 into 3 into 2 table or something of that sort. Thank you very much.